So I'm recording, even though not many students here yet. Well, I hope they will check the recording if they need to see how many elements there and B complement, right? I think pretty much everybody did it absolutely correct. And if someone did not do the exercise or did it incorrectly, we can always fix it. How? Well, email me your answer. Email me the answer. If you fix it, then you can always email me the answer later. Or if you didn't take it, you can also email the answer to me. So, anyways, B complement.
Okay.
Looks like we have two elements and two more, right? We have total of four elements, and that's, I guess, what.
Professor,
Yes,
Professor,
yes, yes, I can hear you.
um, I I did like homeworks from the first chapter and the second one until
Mhm,
what we took last class,
mhm.
like assignments. Do you want me to like take a pictures and send them by email to you or?
Yes, yes, but not as of yet. In about 4 weeks, we have a midterm. That's when the homework will be due. But that's great that you did it. So
You mean before, should I send them to you before the midterm or
I need the whole thing. I need the entire homework, which is going to help
okay, oh, so just
chapter
one
two.
time before the okay, I got
Yes,
it.
so just
Okay.
wait. Well, hold on to it. Don't lose it, please.
No, 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 I will not lose them. Okay.
Yeah, so just hold on to it. That's good that you are doing the homework. Perfect.
Yeah, I catch up all the assignments from the first chapter because as I told you that I was waiting you for to post any assignments, but because I didn't understood the that I was supposed to go through the recording again and repeat the exercise that we took or whatever other exercise was there.
Okay, so that's great. And just wait, and the time is moving. We're already done with week 4 of the class. Can you believe it? It's already half of the half, a quarter of semester passed. So another 4 weeks we'll have a midterm, and that's when I will ask you to send me whatever you did outside of it's called homework. So just wait with this a little bit because I want to see the whole thing. So we are done with chapter 2, and then we'll work on chapter 3 today. So that's the plan. So I told you that I will open the chapter 3, which is called Logic, which is a quite different story compared to what we already saw in the first part of class. I will go for the textbook and we'll continue. Now we start chapter 3. And in this nice chapter 3, in the logic part, first section is just an introductory that may not be making much of sense in terms of solving exercises, but it makes sense as logic. It should make sense. But anyways, let me try to see where the chapter 3 is. So chapter 2, set theory. So we're done with set theory. So we need to move on to the next part, to logic. I'm trying to see, it just doesn't show where to move this. Okay, now it's so chapter 3, 3. Does some funny things. You just need to be patient. Whenever you deal with online classes, what you need is to be a patient. That's the uh, goal. That's the whole point of the story. So if you just wait a little bit, everything will be fine. So in that part, we will see a slight resemblance with previous chapter eventually, but beginning is again vocabulary talks about some type of statements and various other things, various sentences. So we'll be working with statements in the logic class. They trying to make a whole idea what we're dealing with, and that's why they like to have a statement. And statement, they say, is something that could be either true or false. So there could be true statement, could be false statement. And otherwise, it's called a sentence. For example, one says, London is a capital of England. So somebody makes a statement. London, not Paris, not New York, is a capital of England. So is that correct? And some people will say, yes, London is a capital of England. So it is true, it is a correct statement. So statement either true or false, or true or not true, so whatever it is. So that's basically all we have here for the beginning. So I want to move on and call these statements not with sentences, but with various symbols for convenience. Because otherwise you'll have to write every time London is the capital of England. And what they do in math, they try to use mathematical symbols. So they say, okay, let's call it as statement P. They say, why P? Well, usually they like to use letters P and a Q, so they like to call it as P. And for P, they say P is true, so true statement. That's something we already encountered in the chapter 2, right? So good thing to see that we continue with similar ideas. So we enter in the names for those. So we're gonna do it in abstract way. We're gonna utilize some letters instead of sentences. So that's how math usually is being designed. So now we're gonna work with those statements, and looks like they keep using the same thing again and again. So how about if we try to look at some statement like today is not Monday? Well, today is Wednesday, right? Today's Wednesday, so this seems to be correct statement, but that's not what they want. What they want is to say negation. Negation. And when you negate, you get the opposite. In other words, you say, no, today is not Monday. No, that's not correct. So two negations mean it is Monday. See, what did you just say? Well, today is not Monday. What will be the opposite statement? Today is Monday. Today is Monday. So you enter negation or you drop it in order to negate what you have. So not Monday, then the opposite will be Monday. No, you just put not Monday, which is canceling each other. So you just get rid of that not and you have Monday. Let's look at more of these ideas. In fact, it's probably a good idea to look at the exercises, and that way we'll feel a little bit better about this negation thing. So I'm gonna try to get to exercise set, I think here. Tables, no, 3.3, I think. Okay, 3.3, there. All right. See, there's a little inconvenience. I keep on being unhappy because of that. But we have a free textbook, so it's not too bad. So let's look at some exercises. So it looks like they have P and Q, the two statements that will refer to exercises below. And the first statement, 4 plus 6, is correct because it is indeed 10. You say, I can verify it using a calculator. Yeah, if you want to, you can do it. 4 and 6, indeed, it's 10, right? But the second statement, 5 times 8, should be 40, isn't it? It's not 80. And that's okay. You will just say it's false statement. It is not correct. Remember, those statements could be either true or false. So we need to determine the truth value for each statement. For example, if they say, what about not? They say that way we think means not Q, not Q. Remember, we used a complement, we used a prime above in the previous chapter, but in logic, they like not, which means the same thing. Well, not Q.
It's true.
It is true, absolutely correct. Because notice that Q itself is false, and not Q will be not false, and not false is same as true. Same as true, so it is true statement. So if you negate incorrect statement, it becomes correct. And if you negate correct statement, it becomes incorrect. So I hope intuitively we can see that. Well, how about exercise 3, P and Q? What does that mean? Well,
it means true and false.
yes. So we need to define what and stands for. I'm trying to write and. Need to start over again to put and. Need to be patient with this. So and. Please notice that we have the analog. Why is it so thick? It's too thick. Oh, because the line is very thick. I get nice and thin. Not. See, it needs to be adjusted sometimes. I don't know why this is changed. It wasn't like that before. So P and. Remember analog of and that we already saw when we had intersection. In the previous chapter, it was intersection. Well, here it is with a sharp like peak here, which is very similar. So it turns out that now I need to introduce you with some more of a definition, they say, because it looks like we need to first of all come up with so-called truth table. And that's important to realize that if you have a P and if you have a Q, that's what we're having here, P and Q, then for the possibilities, it could be either true or false, right? So statement could be either true or false. One say, wait a second, Alex, this is true. Yes, but it could be called as P just about anything. So it could be true statement or it could be false statement. But then, again, if you try the other one, like Q, it's also possible to be true or false, right? So I'm producing so-called tree diagrams. So I try to show you all possibilities that we can have. So true for both. First true, the other is false. Maybe I'll put P. And then also, if you start with a false statement, same two possibilities, true or false, are possible for the other one. So what I can go with is both of them could be true. True and true. Or P could be true and Q could be false. So I'm not right now doing the exercise here. I'm trying to show you in general what the possibility is going to be for all exercises that we ever encounter in this textbook or anywhere else. So now I go with a false. So it could be that both of them are false. So maybe I need a little bit of room here. So I need to clear this mess. And go back to my, so false could go with both false, or one of them could be false and the other could be true. So that's how we start all of the tables in logic. So we start with 4 possibilities. First of them will be both true, then true, false, then false, true, and false, false. Well, you say, Alex, what if I start to mix it up? Well, it may not be as convenient. That's why I will always use the same start. And then we define the P and Q to be true only when both of them are true. Because otherwise, it will be false. So if both of them are false, we have false. Somehow you could get a little bit of intuition if you look at the overlap of the sets. Let's say it's P and this is Q. So here is the part that belongs to both, so when they both are true. So P is true and Q is true. But if P is false, actually it's like not Q, not Q. So it's like not Q, Q is here, not Q is going to be false because it's not in Q. Or if you're looking at not P, that will be outside of P, so it is still false even though it's in Q. And then if neither P or Q is correct, then it'd be somewhere on the outside. So the only case when intersection works when we're in both at the same time, N and P, which is true, N and Q, which is true. So this is the way to think of this so-called definition. And again, that's definition, which means we need to remember. Or I recommend to just write it down on a piece of paper and have it handy. Have it handy for this particular chapter because we're going to have lots of exercises here. And if I try to now use this definition to do the exercise 3 that says P is true, right? And Q is false. So I'm going to end up with thinking how I deal with first of them being true and the second is being false. Well, true for the first, false for the second is a second line in this table. It means the outcome is false. So again, for both of them need to be true in order to have the result also true. Otherwise, it's always false. And that's a definition of the so-called AND statement, which is new thing. And it is in the beginning of this, I didn't look at this part yet. So, but that's really all we need, the definition. So let me do the similar exercise. Let's say clear this mess below and do next one. Let's say part 5. I'm going to say, why not 4? We'll do 4 also. So 5 says not P and Q. So what is not P?
False.
So it looks like not P is false. That's absolutely correct. Very good. So not P is false because itself P is true. So not P
So we negate the true.
false in here. And then the other is
Q is false.
Q is also false. Absolutely correct.
False and false is false.
False and false? Exactly. You're going now with the last row here. So the answer is false. So what's the answer for this exercise? It's only one letter, either true or false. And whatever it would do before is to help us to get this end result. So I can try another one. How about number 7? Not P and not Q. So please notice I will keep using this table with end for all of these results. But first of all, I need to see what is not P and what is not Q.
Not P is false.
Yeah, we just did it, right? So we just saw that.
And not Q is true.
Not Q.
And the result is false.
It's not Q is here, right? Q is saying false. So not Q is going to be opposite, true. Okay, so false and true. And now look at my table. And again, the answer will come from, looks like from row 3. So it'd be absolutely correct. So you're very good at this. Let's try number 8. 8 is interesting. So what we're gonna have for the 8, if you take Q and not Q, well,
it's false.
Well, yeah, absolutely correct. So what you do is don't think too hard. In math, you don't want to think too hard. You want to write things down. So what you do is take Q, which is, let me again
false.
Write the row.
And true.
False for the Q.
Okay. It's false.
And if you go with not Q, that's true. We just did. So all you care about is once again false and true. So now we're taking the second row. No, the third row. Should be careful. See already. Note that. So false and true is here. You say really? Yeah, false first, second, true. You see false and true, and the outcome is here. So our answer is what we care about. The answer is right there. It's what I write in this. So even though it's Q and not Q, and one can start thinking and getting confused, don't get confused. Just break it down to false, truths, and pull the answer from your definition, from your table, just like that. So that's something definitely different. Yes, it's very abstract. Turns out the abstracy in logic is what we're working with. So now I'm gonna take a look at another part of the story, at the union analog of union, which is or one or the other. So if I try to get, instead of n, something like, we have an exercise number 10. And again, we need to, first of all, declare what definition is going to be. So let me again, P, Q, and then the definition of P or.
Like a letter P.
It's an analog of a union. And that's what we also already a little bit familiar with, or union. So 4 possibilities. So you see the start for the table is the same. So P could be true and Q could be either true or false. And then P could be false. And again, Q could be either true or false. So that's what we have for every table. When you say, Alex, is that all? Well, try to come up with the 5th one. So true, 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 false, false, true, and false, false. If you feel like it, practice over the weekend, but believe it or not, you will not be able to. Or if you will be able to, you will become world famous because you will create a new chapter in mathematical logic and everywhere else in math. So anyways, the only case when it is going to be false is when both of them are false. turns out. That's the way to
Mm.
remember, because otherwise it's always going to be true. And that's the case for the union. That's the case for the union. And I guess that's what I want to try to justify. And to justify again, I can recall the definition of union so we can relate to what we already saw previously. So now we have two sets, P and Q. And then union will be everything that is covered by either first or the second set, which means that if we are in either P or in Q, we always say have a true result, even though we may not be in a Q, so like a second one, not in a Q, but in P, which means we're here. And we're not in a Q, so we're either here or there, doesn't matter. The result is we're in the union. And analogously, it's when we're either in false or false, so that's when we're in the outside, right? That's the false for everything. So I guess you can think about it. It's not that obvious, but I think it relates again with the union, and analogously, this check mark seemed to be really a union-like presentation. So I think I should clean the mess a little bit so I can do a little problem for you. So what I can do is, first of all, recall what we're given, because we need to know is P true or Q false. I think that was the case, but I think I need to scroll it up a little bit so we can refresh our memories and see what. Or not really. Oh, now it's unfrozen. But sometimes it happens. Sometimes computer gets a little mad or feels like it's a weekend, which is good. It's good feeling. It's coming. No worries. It is coming. The weekend is coming. So compute more and we'll be there. So anyways, it's got unfrozen and that makes me very happy. That's great. So anyways, I'm going back to this P, which is true statement, right? 4 plus 6, and 5 times 8 was 40, not 80, so that's not correct. So this is false. And using this tool, I'm going to look at start exercise 10 that says P or Q. So P is T
True
and Q is.
or false.
You see, how did you know that? Well, they gave it to us. It's given. See, they gave us. It could be something else, but for this particular entire group of exercises, that's the way it is. They gave it to us. They must give it to us. Otherwise, we have no idea what that means. So anyways, what do you say?
It's true.
Or, one is true. That's good enough for the whole thing to be true. That's the second row, right? P is T, the other is F.
Wolf, yes, the result is true.
The result is true. Exactly. I say, Alex, I think you promised us to do one of these somewhere like 4, right? Why don't I return back to it? I just recalled that I told that we can do this Q or and P. So Q and P, but now it is from the other table, but they switched Q and P. But it doesn't really matter. Look at this. If we have a Q on the first place, it is false, right? False. And if we have a P on the second place, it is true. So now I don't really care. It's P and Q, or if you switch them around, the point is F on the first place, T is on the second place. So we have this third row that spits out F or false answer. So you can call those any way you like. In fact, notice that they do commute. In other words, if you switch T and T, it's still going to be true. Or if you switch T and F, it's going to be actually the third row, which has given you F. And if you switch them around again, F and T, that'd be bringing you to the second row, right? If you take this two and switch them around, then it will become T and F. And the result is the same now. So looks like when you start to commute this T and F, the result is the same. In other words, I can say if I switch, then the same thing will go in Q and P. And by the way, so the same outcome. By the way, the same is true for the OR. So we don't really care which set is first, which set is second in our intersection. If we switch them around, the picture is not really going to change. It's going to be just letters that we rename those things, but the picture gives us the same result. And that's good to realize, because in arithmetic, let's say if you add 2 plus 3, it's going to be same result when you add them around, 3 plus 2, when you commute those numbers. But when you subtract, it is not the same. It's not going to commute. It's not going to be equal, because one will be positive one and the other is going to be negative. So some operations like addition you can commute, and some operations like subtraction or division you cannot commute. And the similar thing here in logic, so you can commute P and Q, so and as well as or you can commute, but some other operations, turns out you can't. I say, what other operations? Well, we need to see other operations. We'll do it next time. I think I'm already overloading you, but just to see the resemblance. So some of these nice operations commute, and that's a new operation, like addition, subtraction, when I say multiplication, division, Alex. Yes, you can exponentiate, right? Let's say 2 cube, 2 to the power of 4, so you can raise to the power as well, right? And maybe you can do some other things. Let's not worry about that, but I'm just trying to say that we can also make or one or the other, even though it's in logic, but kinda analogous. So let's do a couple of more, and then I will ask you for one of those for the quiz. How about that? So let's try 11. So what about P and not Q? Well, I need to know what not Q is, of course, right? So what is not Q? Well, if it's false, then the not Q will be true, right? Opposite. One is false, the other is true. The opposite. Always like that. So anyways, not Q is true.
True and true is true.
And the first one, as you said, is true. Yes.
It's true. Yeah.
Very, very
True or true, it's true.
true and true, true or true. And that we're using the first row in this table with or. See, the important part is to know where to look at. So to have these two tables available, that's why I highly recommend you to get a piece of paper and to write them down. Of course, next week on Monday, we'll write them again, but it'd be a good idea for you to have it somewhere and to know where, because otherwise sometimes people say, oh yeah, Alex, it is in one of those lecture recordings, so I can look through these recordings later next month, and you will probably start and give up because it'd be very annoying. That's why I'm saying a good idea to put this in your formula sheet, because for sure on the midterm there'll be another exercise that will expect you to use these tables with and or. But of course, we need to do more to get used to this better. So anyways, let me do another one. Let's say, how about 12, one more, and then I'll do also 13, and then I will ask you for 14 on the quiz, for the little quiz. I think that'd be fair, right? So let me do two more first. So not P. What is not P? Well,
False.
false, exactly, because the P itself was
True. So not true is false.
perfect.
And or Q, it means or false. The result is false.
Yes, and that's the only false. How about that? That's the only false
Mm-hmm.
in this table, because others are all true. Okay, let's see. So we got lucky. That doesn't really matter, but it could be true, could be false. We don't really care. One gets upset, says, "Oh, Alex is no good. It's false." It's okay. Take it easy. It could be true, could be false. It's just the answers, and that's it. So 13. Let me do number 13, and that deals with the pair of P's, and one of them is T, and the other
True.
is
False.
yes. Very good. So
And
one,
the answer is true.
the other is false, and the answer is true.
True.
How come? Well, that's what tables tell me. You should not really take it personally, please. One is true, the other is false. That's all. What comes out is true. I say, I remember, Alex, we just did something, and it was with Q and Q or something like that, and but that was and. You see, that's different operation. It's or. So that's why I don't memorize the answers. Just look at the table, T and F. It is indeed coming out T or, sorry, or F. It is, again, the second row looks like it is coming out as a T. That's it. So anyways, enjoy the quiz, number 14. Please do number 14, and after that you can have a great weekend. You can log out, you deserve it. You've been through so many new things today. I'm very happy we got to this point. So Q or not Q is a little quiz for today. Remember what we did last time? You use this chat and make sure you don't hurry, please. Just put it only to name Alex. Don't send it to the whole class, because you might say it's false and the answer is true, and the whole class will copy false and say, you know, this student.
You just want the last result?
Yes, because the answer is only either T or F. So the answer is what
I sent it.
you put it there. Perfect. Very good. So you can just enjoy the rest of the day. Have a great day. Thank you for being here. Feel free to log out.
Can I do this exercise as an assignment again?
Yes, absolutely. I asked
Okay.
3 any problems you like. If you want to say, I don't like it, Alex. I like number 7. 7 is my lucky number, Alex. I want okay, do 7.
Okay.
It's up to you. And
Okay.
if you want, I can always do some 7 for you next. So thank you for being here. And
Thank you, Professor. That's all?
is in the correct answer. So that's all for today. Have a good
Okay. Have a good one.
and have a great weekend.
You too. Bye.
So once again, we have a little quiz for today, exercise number 14. So please tell me, is it true or it is false? Or if you're not sure, don't tell it to me right now. Think about it, or you can think about it over weekend if you feel like it. So next time I'll do it for everybody. Next time, which is going to be next Monday. So far I have very beautiful answers. I love when you correct answers. This makes me happy. It makes me to have a good weekend. So thank you for getting good answers. So don't hurry, take your time. Yes, everybody has it absolutely correct so far, so that's great. Just don't hurry. So again, the question is it true or it is false? Q or not Q? Exercise 14. Or if you need a little more time, if you need to review the lecture we just had, you can look at actually exercise 13. It's very similar. So you can review it and then you can email me the answer. Just email me and say, Alex, it's T. True. That's it. Exercise 14 is T. Because it's good for me to know what's exercise 14, what's your answer. Because sometimes people answer exercise from previous week in the